What is sound? Sound is a form of energy produced by vibration of bodies. It requires material medium to propagate. The speed of sound wave is 330 meter per second. Then what is a wave? Wave is a periodic disturbance propagating through a medium carrying energy. A wave is described in terms of its frequency f, wavelength lambda, and velocity v. These are related by the equation v equals to f lambda. A normal human ear can hear sound waves of frequency ranging from 20 Hz to 20 kHz. These frequencies are called audible frequency. Based on sensitivity of a normal human ear and frequency of the sound waves, they are classified into three types: infrasonics, audible frequency, and ultrasonics. Infra means below and sonic means sound. That is, the sound wave frequency below audible frequency, that is below 20 Hz, are called infrasonic sound. Ultra means above and sonic means sound. The sound waves whose frequency are above the audible frequency of 20,000 Hz or 20 kHz to 500 kHz, that is 5 into 10 raised to 5 kHz, are called ultrasonic sound. The branch of science that deals with the ultrasound is called ultrasonics. Uses of ultrasonic waves. Ultrasonic waves has a large number of applications, such as number 1, industrial uses. They are used to study physical properties like elasticity, configuration of atoms in a medium. Ultrasonic sound waves used to mix different elements uniformly to manufacture alloys. Ultrasonic sound waves are used to mix immiscible liquids used to prepare paints, face creams, photographic film emulsions, etc. They are used in dry cleaning of greasy and dirty clothes by ultrasonic sound waves. They can be used to detect cracks and flaws in metal moldings. They are used for welding, local heating, and drilling small holes in hard materials. Ultrasonic sterilization of milk and milk products destroys bacteria and keep the dairy products fresh for long time, and it is easily digestible. Number 2, medical uses. Ultrasonic waves are used as insect repellent, helpful in agricultural fields. A vibrating metal head at ultrasonic frequency produces a massaging action, relieving rheumatic and neuralgic pains. When sharp instruments are focused by ultrasound waves, they vibrate at ultrasound frequencies, and the surgeries are conducted with a minimum blood loss, called bloodless surgery. When ultrasonic sound waves are focused on the kidney stones or gallstones, they get cracked and reduces in size and gradually come out of the body through urine. Thus, kidney stones or gallstones can be removed without surgery. Number 3. Used in sonars. Sonar, it is the acronym of sound navigation and ranging. It was invented by Paul Langevin, a French physicist. Ultrasonic waves used by sonar to measure the distance, direction and speed of underwater objects like icebergs, ship wreckages, rock, mountains, submarines, etc. Principle of sonar. Sonar works on the principle of echo-ranging. Echo-ranging is the phenomena where the distance of the object is found by the velocity of ultrasonic waves in water and time interval between transmission and receiving of ultrasonic waves. Working. Sonar consists of a transmitter and a detector. Transmitter produces ultrasonic waves and transmit them, which travel through water until they strike an object. They get reflected and are sensed by the detector. The detector converts the ultrasonic waves into electrical signals, which are approximately interpreted. If t, the time interval between the transmission and reception of ultrasonic waves, v, the velocity of ultrasonic waves in water, that is 1.5 km per second or 1500 meter per second. D, distance of object from the sonar. 2D, distance travelled by the ultrasonic wave. Then velocity v is equal to distance travelled by time taken, v equals to 2d by t. Example: a ultrasonic sound signal sent by sonar takes 4 seconds to return. The velocity of sound in water is 1.5 km per second. Find the distance travelled by signal and distance of object from the sonar. Given that time interval between emission and reception of wave t equals to 4 seconds, velocity of ultrasonic wave in water is v equals to 1.5 km per second, total distance travelled by the sound wave equals to 2d have to be calculated. Distance of the object from the sonar d have to be calculated. We have v equals to 2d by t. Therefore, d equals to v into t by 2, that is 1.5 into 4 by 2 equals to 6 by 2 and equals to 3 km. That is, the distance of the object from the sonar equals to d equals to 3 km and the total distance travelled by the sound wave 2d equals to 6 km. Ultrasound scanners. It is an instrument which is used to get the images of internal organs of human body with the help of ultrasonic waves. Working. When ultrasonic waves are directed towards the internal body parts, the waves get reflected back by them due to change in relative densities. Example, liver and pancreas. The scanner provides images in a static form or a movie picture form. Uses: ultrasound scanners is usually used in examining fluid filled organs like urinary bladder, gallbladder, kidney, heart, spinal cord, brain, pancreas, etc. Heart is examined using ultrasound system called echocardiography. It is done in a machine called echocardiogram, and the report obtained is called echocardiograph. As ultrasound waves are safer and harmless when compared to X-rays, they are also used in examining the growth and other congenital abnormalities of the fetus in the womb. An ultrasound scanner acts as a guide in surgical procedures. Why is this apparent change in sound frequency of the siren? Let us take an example. Let fire engine be the source and a man as an observer. Both are rest at the beginning. Then the observer hears sound from the fire engine is of same pitch. When it started moving towards him, the observer feels sound to be of higher frequency and maximum when it is parallel to him or inline, because the waves in front appears to be compressed. When the fire engine passes the observer, gradually the pitch or frequency of sound goes on decreasing because the waves behind the engine appears to be farther apart. This apparent change in frequency of wave motion due to the relative motion between the source and the observer is called Doppler effect. First predicted in the year 1842 by Christian John Doppler, hence the name Doppler effect. Doppler effect in light. The speed of light is so high that only celestial bodies or atomic sources moving at high velocities show Doppler effect. This is given by red shift, that is, when a source emits light of particular wavelength and the source is moving away from us, the wavelength appears longer to us. The color of the light is shifted towards the red end of the spectrum. This effect is known as red shift. Applications of Doppler effect. The velocity of submarines and airplanes, jets, etc. can be determined using Doppler effect. Radio waves are sent in the direction of the speeding vehicle and the reflected waves are received. The change in frequency of the wave is used to determine the speed of the vehicle by the device called radar gun, used by traffic control authorities. The artificial satellites are tracked using the Doppler effect. Doppler effect is used in many cases of astronomy, such as study of binary stars, study of Saturn rings, study of galaxies, estimation of speeds of stars, galaxies, rotation of sun's disk, etc.